I hope you are well and safe, and you are studying the material day by day. I know that maybe some of you are in not easy conditions, but you still have to, we have to continue with our life, and you have to study. About exams, guys, the cabinet of the university met yesterday, and they left it kind of up to the instructor to decide how to go about his course and exams. We have time, especially in this course, I have at least one grade already. But some of you might say, no, we need another grade and another grade, another grade because we didn't do well in the first exam. Others might say, I'm fine with the current grade, but at least we will do one more exam. And if I can do two, if, then we will do an assessment. Like what? We join Zoom session, one-on-one for 15 minutes. I ask you 3-4 questions. You answer them. This might not be the best way, but it is one way. We will decide. Let's not jump into conclusions now. We will see what is best for everybody. مش everybody. For يعني what is best for most. We cannot please everybody. And then we see what to do exams. We can wait for a week or 10 days before we do exam 2. That will be the end of March. And we have all April new material to do the final, to use in the final. Okay. Now, about the material today. We saw PDP-8 instruction set last time. I went through it and we counted and we saw how it works. And before that, we went into instruction set addressing modes. And I have prepared this as a numerical example and maybe sample quiz questions. Maybe they are in this form, maybe they are in another form, but they mean the same thing. Okay, here we go. Explain the following PDP-8 instructions. I can now increase the font, guys. You know why? Because I'm looking at one thing only. So 16 or something. Yalla, 18. Okay. How do we go about it? Interpreting this? It's 12 bits, unless I made a mistake in counting. I added 0 here or 1 there. So assuming, inshallah, it's correct, then what do we look first to? Anyone tells me where do we start looking? But don't go through. But where do we start with this? Where
The first few bits will tell us
how many?
which
How many? How many? Did you say how many, Mark?
the first 3 or 4
Three.
bits.
Yeah. No.
3.
You start with the first 3 for sure. And then you decide if you're going to go with one more bit or not. So PDP takes the first 3 bits. And it looks here. Are they between 000 and 110? No, this is more than that. You see, 111 is more than 110. Yani, it's not in this range. So it skips this format. It comes here. And here it says, yes, I am in 111. أصلا ما في غيره يعني. So 111. Then it looks for this one bit, you know? So let me color them, guys. So if we say that these are what? في yellow, معلش. And this one now is suppose colored red. Okay, now. Do I have one here? PDP-8 is asking itself. No, I don't have one. I have 0. I have 0. So in this case, what does it do? In this case, what does it do? It looks in these ones, لأنه هيدي 1 وهيدي 1, for a matching one, this is not a 1. هلا I'm talking about these guys. خلاص, I decided that I'm in this area. No, I forgot something. Because this one and this one are the same, then it looks at the last bit to differentiate between the set of these instructions and the set of these instructions. So it looks at the last bit, and I'm going to mark it as green. First, second, third. It's a 0, so now I am sure as PDP that I'm in this area. How many bits I have to look into? I have 1, 2, 3, 4, 5, 6, 7 bits. Let me see. 1, 2, 3, 4, 5, 6, 7 bits. مظبوطين. 12. Now, which one of these is 1? It's the third one from the left. So PDPA, it will go 1, 2, 3. So it's this instruction. What is this instruction? Skip on 0, I believe, or something, SZA. Skip on 0 accumulator. So it executes the opcode skip on 0 accumulator. What do you think it will do? It will go and test the AC, and if it's 0, it will skip one instruction, and if not, it will continue. I want everyone, each one of you guys, to say something. يعني, may say, okay, chat. I'm gonna wait in the chat. Here, I'm in the chat. I want an answer from everyone. Just say yes. Just say I understand. Just say I got it. Yalla. I am waiting in the chat for everyone. Hagop is saying okay. You can do command thumb up or chat with me and tell me. You can say repeat. Are we recording the session? Yes, no? Yeah. Stop recording. God. Yeah, we are. So yes. Okay. طيب. Why don't you do the second one and tell me what instruction we are running? يلا نشوف. The second instruction is even easier than the first instruction. In a sense, ما بعرف. Do the second one. So finally here, what do I want to mark this as? As orange. As orange. Where is orange? Anything or blue. يلا ليش لا؟ ما مبينة blue. لا ما حلو. I want a light color. يلا هيدا. وشو صار؟ escape. We are trying مش هيك with the second one and I'm just putting some time here. شو. Let me see, where am I? Yes, it is better. And I'm gonna number them, guys, while you are doing this. This is 1. Where did we go then? To here. This is 2. To make decision. And then we went all the way to this 3. And then we went back here. معلش. I do 4. And then I do space. In order to make my decision on this as a PDP-8, I check the 3 followed by 1, not all the time, but for this one, followed by 1. This took me all the way to 3. I find that it's a 0. And then I said, it's this instruction. And I counted and I find that it skipped on accumulator 0. Or skip 0 accumulator, it's the same. يلا. Anyone with the second one? يلا. It took us مع كل الشرح, it took me 30 seconds or so. Any volunteer who wants to talk about this, please? Any volunteer? No volunteer? Mark, please help me out. Say something.
So first 3 bits, 110.
Okay. First 3 bits, but give me time so we always start from here. So this was blue, yellow, 110. Then what, Mark?
So it's an IO instruction.
Haha, 110. There is no other choice. There is no other choice. Then where do you go then?
Bits 3 to 8 will tell us which device.
Bit 3 to 8? No, not now. No, you jump to 9 to 11 مش هيك؟ You jump لأنه الأوبكود موجود 9 to 11. The opcode, once you see 111, you are adding here 8 opcodes. The opcode, for example, you are reading, you are writing, you are loading, you are storing, you are printing. ما في load كلهم I my mistake guys. So I am reading, I am writing from a device, I am input output. All the input output that you know are here. So the second step, you go all the way to the last 3, and I'm gonna mark them as green, similar to the top one. هون ما في red دغري. Do you want to mark it as red, guys? So this will be 2. Yes, let's mark it as red.
Yes.
So that will be 2. So this is 1, this is 2. Now I don't care what the opcode is. Well, I don't care what the opcode is. What are these guys? What is the rest here? What does it say? What are these left for, guys? It's not 1 bit at a time. Maybe you don't see. Let me increase it a little bit so you can see the input-output instructions, مش هيك? So this is the device. What do you think will be supplied here? What will be, do you think, supplied here, guys, in this one? The device. The address of the device, yes or no? This is, for example, read. Read from disk, صح ولا لا? Are you okay? The address does not stop here. Read from that device كمان at that address. يعني في كمان شغل زيادة بالموضوع. بس this is how they go. So these are what, guys? If we want to, this is the this strange color. I don't know what it is. Here it is. So this is only 1, 2, 3 only. 1, 2, 3. I can't do better than this. I can't look into your eyes and understand what's happening. Yeah. We go now to addressing modes as examples. And we have this set of registers. There are 4 registers. R0, R1, R2, R3. Varies means that they can have any other value, but we are starting R0 from 0 and R3 from 0. CPU can do this very easily. You remember I told you about the table that the operating system will, with the help of the compiler, will create once you start running a program. Yani if you say integer n, it will it will reserve a data location for it. If you say double m, it will reserve a data location for it. So these are variables, guys. These are variables, assuming variable 1 has 50 in it. Variable 2, you can name them n or m or r مثل ما بدك. Variable 1 is 50, variable 2 is 75, variable 3 is 30. The pointer is pointing to variable 2. So, you know, in C++, we never use pointers, guys, in Java. But if you study C++, you use them heavily. I don't know if in 204 you kept using Java. Sometimes when I teach 204, I change the mode in order just to show students pointers because they are important. So this is like pointer to variable 2. This is how this is interpreted. So if we are doing a class, we would say this, guys. pointer to variable 2. This is in drawing. This is actually the address of variable 2 is put here. Okay, no problem. I have an array. I don't know what's in the array, but it starts at location 200. So بالmemory هون في عندي array here, and it starts at 200. So the number here, I don't know what. 1 أو شو. Let's do it as 4. And then ما بعرف 1 and then 3. Let's write easy numbers here. I don't know. Yeah, خلاص. And the result is an empty uninitialized value. Even in Java, guys, if you start a variable without initializing it, it will be garbage. Unless we are talking about two integer arrays. You remember? They start as zeros, and string arrays, I don't know, they start about a space, or I don't remember. Okay. Now the question. Finally, we have a question. If I stop doing this and now go here, who's going to execute this for me? هلا هذا غير محله. لا صار confusing, guys, لأنه this does not point to this. Let me go here and clear with this. While you are thinking, guys, let me delete this one only. Okay, begun. خلي هيدا الارray, no problem. In case we use it, do we use it? I don't know. Yeah. يلا. Who's going to tell me how do we calculate the effective address and what do we place in R3 at the end? Remember, we are, no, what is in AC at the end? Then we add, oh no, what will be in R3 at the end? لأنه R3 is a register and we are adding to it. Oh, see, let me keep explaining things, guys, on this, what I'm doing here. So this sounds, oh no, I want a pen. What is the pen? So what we are saying here that this is an immediate number. We mark it with #10 in some assembly language. I can just say 10 and it's immediate. And then add R3, R1. I want this to mean, and it can mean different things, huh? R3 equal R3 plus R1. This is what we write in what shall I call it? In our high-level language, T equal T plus N. You remember the accumulator? This is similar to the accumulator. If you put it in a loop, then this is an accumulator. So having said that in this language, the hash means in the immediate. Go ahead now and tell me what the answer is. I'm gonna name students now. Please prepare yourself. عن جد مثل بالصف. I'm gonna ask specific students for answers. Yeah. Joe, do you have an answer, Joe? You just can simply say no. يعني بس chat with me and say no. معلش ما في مشكلة. But at least I know that you are thinking. Chat. Joe. No. Zainab, you can chat with me if you don't want to say something. Zainab, did you figure this out? Maya. Khalil. I have one chat. Let me see. مين؟ ما في عندي شيء جديد. ليش في one new شو؟ ليه ما قال لي what is it؟ not yet. Okay. Not yet, but shouldn't take you long. معلش أنا بنطر ما في عندي مشكلة. هيني I'm waiting. I'm waiting for chat. Livon, are you still with us? Mahyiddin, I'm waiting for an answer. Don't sit, guys, doing nothing, waiting for. I will see the recording. هلا مش فاضي بعدني فايق من النوم. This is not the right way to do it. Joe? No. Harut is not with us. I didn't see his name today. I have one chat. Inshallah يكون مظبوط. Yes, Joe. Joe, answer. True, yes. I want an answer, my friend. Am I lagging? Can you hear me clearly? What I'm saying, what I want from you? I want to run this and tell me what will be stored in R3. And I explained to you this is not saved in the accumulator, it's saved in R3, given this syntax. I want an answer. No. Mark, can you help me, please? No. Let me see if Mark is still. Lana, I didn't talk to you, Lana. هيك هربتوا من الصف شيء؟ لا بعدكم هون.
Good morning, doctor.
Good morning, Lana.
كانت مقطوعة الكهرباء يعني فت
Okay.
أول شيء وانقطعت هلا قعدت فتت.
Okay, أهلا وسهلا. Mark, do you have an answer for this? Okay. Load 10. We mentioned in our previous lecture that 10 is a constant. It goes into R3. So R3 has 10 in it. Has 10 in it now. Loading R3. R3 was 0. Load 10 in R3. This is very simple, guys. I didn't even include memory here. I could have said load 10 in memory of 15. So you have to sort to fill it here somewhere in 15, guys. It just registers here. Register, this is the easiest. Now what? Add whatever is in R1 with R3. Add whatever is in R1 in R3. What's in R1, guys, given here? It varies. It could be any number, right? We could have said here, مثلا -1, suppose. Then adding -1 -1 to R3. شو بيصير ال R3, guys? Load 10. Add this in here. So R3 is 9 now. 10 minus 1. R1, I assumed it's -1. You could have assumed any number, and it varies. Now, R3 plus whatever in variable 1. What's in variable 1, guys? 50. So it's the same instruction here, but I'm changing the -1 with 50. So now, this is 50. And what was in R3 lately? It was the 9. So the answer all in all is 59. And this is it. Any questions on that, guys? Any questions on that? Okay. Let me stop this. Maybe I have a chat or something. No? Okay. Fine. Fine. Now what? I close this. What did I do here? Close this. Okay. Now I can drag down. Now let's look into this. I can clear all this, but let's leave them. Now this is the displacement. Remember the displacement? Displacement needs a base register and a displacement value. That displacement value can be a constant, like in this case. It can be a memory location. ما بتفرق معنا. In this case, it's a constant. Given that the base register is R1. So what is this, guys? هيدي كتير مهمة هاي كتير مهمة. The content of R1 is the base register. So we go up to R1, and what we see in R1? Come in, choose any values. So suppose R1 is now, let's say 101. حتى ما أروح وأعمل. Suppose. Then now what, guys? What will happen now? Here. Base is R1. What is the okay. So in displacement, we have in R1 here as a series, not any number, guys. I go back in my word and I say the displacement came in the base of a register, guys. So R1 in this case should be pointing to, where is the annotation? Should be pointing to the starting address of the array. Where is the array? Yeah, array start. Array start. Let me clear the previous ones. No, we don't want them. This will clear, will look better. Okay, بعد من memory. وهذا ما بدنا إياه. Okay, now it looks good. Okay. So now I go back to the pen. If we look here, guys, this is the displacement. So R1 is pointing to the start of the array. So this is the link. So this will be this location in the array. Where is it? Here. Array starts at 200. So we scratch, مش نحن, the language or this, we'll scratch and put 200 here. Being what? Being the base address of the array. Now we add to it 5. So plus 5. And this will be the effective address, guys. This is the effective address. So memory at 205 will be stored in R3. What's in 205? You can guess. مثلا memory 205 has in it مثلا what do you want? What? I can choose a number. 13. Why not? So the end of this instruction, guys, will say that R3 now stored in it 13. منين جبت كل هالمعلومات? If you listen to the previous recording, guys, when we were talking about displacement, we talked about the register being the address of the starting address of the array in memory. Please repeat and see. Repeat or go through recording one. What about the relative address, guys? هلا مين بده يجاوبني على شيء? It's not here. We finished whatever we were doing. Who's going to tell me the relative address? What did we say after displacement? There were a relative address or something. After displacement. It is the same, but it picks up its starting address from the content of PC. And we said that these are used for jump. So you add to the PC 5 or minus 5, and this will take you minus 5 instructions from where you are now in the program. This is for or while loop, or plus 5, and this goes for the jump. I'm going very easy. I'm repeating myself. I'm giving numerical example. Let's hope that everything is okay. طيب. Finished with this. I think it was good to review and to clarify few issues. If I give you something like this in the exam, guys, I'll be more specific. مثلا بدل ما أقول varies, I will develop a number that here has a starting حتى لو ما كان بيعني شيء. بس I started مش بقول لك assume it's -1 بحط لك -1 شو المشكلة يعني ما في مشكلة. Okay. Any questions on this before I move along? Let me clear the screen, all drawings, and then stop this, and then stop this. Don't save. Did we change anything? Don't save, خلاص. Are we using this anymore? No. So you can check yourself, guys, with any 12 bits. Just throw in randomly. Let the random number generator give you a 12 bits between 0 and 1 and figure out what's the instruction. خلاص ما بدها شيء. Random number generator will give you 12 bits between 0 and 1. طيب هيدي خلصنا. Yes. Now we go to our chapter today. واللي هو chapter 12. Is this the one? والله هيدا chapter 12 هيدا. And here we are. Okay, this is chapter 12. We are still in instruction, guys. CPU now. How CPU will go about. Let's see now how clear we can see this control plus control this one. Can we do control plus here? No, it's not incrementing. I want to keep seeing what's happening here. طيب خلينا نفتحها بعد شوي. Okay, I think this is clear. طيب. CPU structure and function. Now, CPU structure, guys, we saw von Neumann CPU structure. Yani, this is what we mean by CPU structure. Structure كان في عنده MBR that receive as a buffer an instruction of 40 bits into the CPU, then split it into 20 bits and another 20 bits. The first 20 bits put in a IR 8 bits and in an AR 12 bits. And then comes what? The functions. What are the function, guys? The logic circuit, صح? The logic circuit has 21 instructions. But more than that, guys, we don't say in our instruction set PC equal PC plus 1. So the CPU has to do it by itself. In your instruction, you don't increment the PC. So when you fetch an instruction and execute it, the CPU has other things to do other than executing your instruction to keep things running. So this is the functionality of the CPU. If you say مثلا R3 equal R3 plus times 2, guys, he might do it through ALU, or the CPU might decide to do right shift, left shift. لأنه left shift is times 2, right shift is divided by 2. كمان we mentioned this before. Arithmetic is with sign, logical is without sign. So this was my introduction. Now we go here. CPU structure. We know about fetch instruction, interpret data instruction, fetch the data, process the data, and write the data. We have said this from the beginning of the semester when we had that chart about instruction format. He's not repeating this, and this is the general format of a CPU, guys, with ALU, with control unit, which is the logic circuit, and with set of registers. Where is the cache? It's not there. No, he's just specifying the. I have to chat. What did we say about the exam I joined? No, عندي 2 جديد اللي تشوفهم شو هني. مين هيدا؟ ليفون شو عم تفتح ليفون؟
Yes.
ليفون you have a screen that saying okay حدا عم يشجعني يعني okay maybe حدا عم يشجعني. thank you my friend. Joe 6 and 7 ما بعرف شو يعني 6 and 7 from Joe as shoe as by the way Yvonne I can't see this person encouraging me so
Yes, it's meant to agree with
let me see if
what
I
Joe said.
maybe let me see if I see your name. I'm learning something guys here. No, let me see Livon. No, Livon is just the camera and fixed. So it's not playing that video. Anyways, we continue. It was a break for me to see the chats and if there is something important in there. So you know that CPU has lots of other devices in there. If we call them devices, modules, something, cache level 1, cache level 2, data cache, and instruction cache. We know that different set of registers for a different type of CPUs, whether it's power computer, يعني this computer or sys computer, and so on and so forth. طيب خلاص خلصنا. This is the general format. Now here, start the connection. This is the system bus, guys. No, this is the internal bus to the CPU, sorry. And it connects all these together, whatever you want to do. So the control is controlling everything. You see, control has a way to send control signals to the registers. It goes to the bus and can go directly to the arithmetic and logic unit. In the arithmetic logic unit, we didn't see what's in there, guys, but usually the arithmetic calculation and arithmetic and logic calculations, which to see if two numbers are, you see this, the shifter, shift left, shift right, shift many times, I don't know. So again, this is the internal structure of the CPU. Again, not mentioning cache memory and how to deal with cache memory. Okay. Registers. Now we're talking about registers. Must have some working space, temporary storage. Register, we said mainly 16 registers in CISC, and for each running process, maybe 32 registers in the RISC computers. طيب. Within those registers, guys, within those registers, we specify some of them to be user visible register or not user visible registers. A stack pointer, guys, is not a visible register. PC is not a visible. They are registers. They store data. They are updated by what? By the system, not by the programmer. The programmer says push, and then it will be executed like it will go to the top of the stack. Stack pointer points to the stack. ما خصك انت وين موجود. And then it pushes something in there and increments stack pointer by 1. So this is a non-visible register. Cannot go directly to MBR or MAR or okay. Now there are visible register to the user. مثلا لنقول AX, BX, CX, DX. Usually this is what they name them. But listen to this command. Some of them are general purpose. Some of them are special purpose. Oh, what do you mean by special purpose and general purpose? General purpose, you can use that register for anything you want. You store a value, you can have it as a memory indirect, you can have anything you want. Visible, special registers, guys, مثلا counter, AC. Sometimes when you do a loop in assembly language, you just mention the word loop with a label. Loop with a label. Let me annotate this. So I have a program in assembly, and I have something here called label 1. And here we say jump loop عفوا loop. This is the opcode, guys. Loop L1. This is a legitimate syntax in many assembly language instruction set. And we know that assembly language, most likely, they are one-to-one with the instruction set in order not to take time to interpret again and so on. Let's go back to what I was saying. How many times you will go here back and forth? This is like a loop, you see? Go loop, 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 loop. There is usually, there is a register, RC, for example, register counter, or we cannot call it AC لأنه AC belongs to the accumulator. هيدا كل العالم تعرفها. AC خلاص accumulator. RC is for accumulator, for example. For counter عفوا. So this can be used as a general purpose register to add, multiply two numbers, and can be used here as an auto increment to know how many times this loop has to go. So before you go into this loop, you say, for example, RC equal to 5. طبعا ما في هيك. You load RC, 5 or something. And then when you go into this loop, this will go without you saying anything. Every time you go back, it takes one out of this. So this is 4. You go back. انت ما عملت له شيء. بس هي اللوب instruction, guys, is doing that. ما اللوب هي مثل when you did the von Neumann program, you said, if this instruction is this, then do that, and this, and that, and this, and that. This is exactly what happened here. You do this, and that, and this, and that, and this, and that. When you hit the loop, you check. مش انت. هو الأسمبلي language will check RC, not any other register. So this is general purpose register, yet specially used at some time. So we differentiate our registers between user visible and user not visible, يعني system registers. We said PC and stack pointer. When we come to the user visible register, they can be totally general or for specific use. And I gave you an example of this RC, how it works. You set it up and you don't say decrement, it will decrement. لأنه this opcode is decrementing exactly this register. I hope you understand. Called register number and function vary between processor design عددهم وكل واحد شو شغلته general purpose ما general. One of the major design decision قولوا لي أول شيء what does it affect, guys, on something we have seen before. One of major design decision when you are designing a new instruction, a new processor, a new CPU. You want to decide on the number of registers inside the CPU. What will it affect? Obviously, it will affect risk and CISC, لأنه if there are too many, like 32 for each, then we don't need every time to load something. We load it once and we use it all the time. Having said that, I mentioned this also today in the recording. What about other concerns? Why don't I make them مثلا 100 register? شو عليه؟ يلا زيدهم. Why don't I make them 1000? شو هالحكي هيدا؟ يعني هيدا صرت كأنك عم تعمل cache memory, guys, of 1K. لأنه the smaller the set of register, the faster that you can get the data and use it. If you're gonna make it 100, and then how this 1000 will affect the instruction set, guys, also. Other than register set very large, بتصير كاش ما خلص بطلت set of register, guys. يعني maximum 128 registers. There could be more, guys. 128 registers in the CPU cut into 32s 32 and كم واحد بيطلعوا 32 times 4 مش هيك 32 times 4 بيطلعوا 128 if I'm not wrong. Then this is process 1 will take the 32, process 2 will take the second 32, and then the third, process 3, and process 4. And if you are up with the material, what happens if I go and I want to run P5, guys, process 5? Tell me what happens in this risk setup. Anyone remembers? Okay, we said it looks like a circle, so it will go all the way back. It will take this out and put it in a buffer somewhere. It saves it. Place P5 instead of P. So this is context switching, guys. Finally, we do context switching. P5 بيقعد محل ال P1 and then it runs to finish. When it finish, then what do you run? It will return لمين, guys? It will return to P4 لأنه P4 called P5. P4 was running when we called P5. So it goes here and yalla, return, yalla, return. And then it comes here again and it says, I context switch P1. So it gets P1 back and resume execution. Okay. Okay, this is what effect happens on the number of register and how many. What is the effect on instruction set, guys? On the instruction set, one major design decision. Why does it affect the instruction set? Okay. Instruction set is number of bits from 0 to 31. Functionality will compete. Functionality will compete for these bits. شو بدك؟ Functionality. How many opcode do I have؟ ما فيها مزح. بس فيها smart decisions like in PTP8. They are not fixed. Then if I needed 36, I don't remember how many instructions we had. Suppose PDP 8 or 10 or 11. They need مثلا 36 instructions. Then how many bits we would have registered for? 32 is 5 يعني became 6 bits. He got away with 3 bits, guys. 1, 2, 3. He got away with 36 instructions. كيف؟ صار يلعب على الموضوع. انه okay, I start with 3 and if it's not this and that and this and that, then I go with the fourth one. And if it's this and that, I go to the last one. We just explained that when we were doing our numerical example. So what I was saying, that functionality is competing. What else can go here? This is the opcode. Okay, خلصنا منه خلاص بأقل مشكلة ممكنة. طيب, I want registers. And also I want memory. You know what? Maybe I want memory to memory operation. كيف هيك؟ شو الحكي هيدا؟ Yes. Add memory location 1, comma, memory location 2. This will consume all the bits that are in here very fast. شو memory location? How many location you want to go directly, مش indirect? You want to go to 1K, so you need 10 bits. So this is 10 and this is 10 if they are memory to memory. This is 10 and this is 10. Okay, we cannot do a 16-bit computer using this kind of format in an instruction set. So we don't go memory to memory, guys. We go, for example, register to memory. So this will be 10. And we said that this is 6, مش هيك? We said this is 6. What will happen here? No more space. Suppose this is 16-bit. أخذت 10 in order to get to 1K of memory. لأنه عندي بالinstruction set memory location up to 1024. So I need 10 bits here. ما في لعب بالموضوع. and we said 6 bits for opcode. طب منين بدي اجيب register guys؟ شو الحكي هيدا؟ Then this will be what guys? This will be, if I want to keep this will be a one address instruction set. Let me draw it here. And it consists of opcode and show and memory location. memory يلا اوكي memory location. هيدا 6 وهيدا 10. طيب ما عادش عندي شيء بتلعب فيهم. Will this work guys? Of course. لأنه we said in the instruction set format that we can live with one memory with one operand instruction. We even said we can live with 0. You remember? 0 instruction. واستعملنا stack by default, top of the stack. So this one is doable. ليه؟ بتقول له مثلا load whatever in memory 1. بيروح لوين بحطها؟ بالاي سي. add memory 2. بيجمعهم. store in this. خلص بيمشي الحال. But what is the problem with this kind of CPU instruction set? Every time you are referencing memory. So this will be slow. Every time we'll be referencing memory. So we'll be slow. It will be slow. But it works. But what can I do here with this? If we go back here, guys, you know what? I didn't have 36 instructions. Actually, I had 32 instructions. 32 instructions. So I don't need 6. I need only 5 bits. What am I left with? 5 and 10 is 15. Plus 1 is 16. So I have here 1 bit that I can use in my design. I'm designing. I'm trying this. I'm trying that. Okay. 1 bit. Okay. Is that good? To a certain extent, yes. Why? Because now in my CPU, I will be having 2 registers to help me. Register 1 and register 2. ليه 2 register؟ لأنه 1 bit 0 يعني register 0 1 يعني register 1 وماشي الحال. Now I can have instructions like add register 1 in this computer register 1 and حد شو بيكون فيه memory address. Cannot get easier than this guys. This is the material. يعني إذا حدا منكم عم بيقول oh my god أوبا ما بعرف شو, this is the material. You are designing a CPU of a computer. It's not as simple as writing a line of code. No, it's not like that. Major design decision لأنه it will decide on how many bits you are going to be using in your instruction to specify a given register. Okay. Also, we said that it affects the number of registers that are placed, the number of registers available. Not only the instruction set, it affects the memory, يعني the number of registers within the CPU. غير ما يكون عندك 128 register غير ما يكون عندك 16 registers. Top level of memory hierarchy. خلصنا من هاي. What does that mean? Top level of my memory hierarchy in what, guys? In what? In price? In speed? In length? In what? Top level of memory hierarchy. When we talk about memory, guys, what we are concerned with? Space. Space, مش هيك? Most likely space, and also how fast we can reference it. So it was somewhere. Maybe we'll see it today if we haven't seen it. But we saw it, I think. So in this pyramid, guys, we have here registers as top hierarchy in speed to reference and size here of the register The size of the register can take me all the way if I do it as indirect addressing register. It can take me to a longer space in the RAM. So this is the direct space of the RAM, and this can take me to the bottom. Come in, we talked about that. Okay. Let me stop this. Let me go. Do you have any questions on this before we go? Okay. Now I want to go down. I talked about this user visible registers and not. كل هول guys كل هول user visible. User visible مش بتشوفه بعيونك يعني. User visible it means you can reference it and use it. This is what we mean by user visible. General purpose بتحط حيالله رقم بالريجستر بتشيل حيالله رقم بتحط ادرس بتشيل ادرس. It's general purpose. Only data, then some of them will carry only data. ليه؟ لأنه these are the ones guys that usually talk with the ALU. So if I annotate again and yeah, then literature draw ALU like this, guys, and this and this. Most of the time, this is just my design, guys. This is the AC. And who's going to tell me where this will point to, guys? هلا هيدا بدي اعمل له pointer لهون هيك. Who knows what will I draw here? A set of registers. All this is inside the CPU, مش هيك? So these are the registers. So for you to go into the ALU to add plus, minus, multiplication, division, you must have in this register data. So this is why we say specialized for data. So you store the data here, and suppose this is R3, and مش واحد بس R3, R4, R5, R6. Okay. One of those that are specialized for data will go here, and the result, where will I go from here, guys? What do I answer this? Where do I go? Where am I going? I'm going back to the AC. So take whatever in AC, add it to AC, so to this register of data, and take the register to AC. Now, if I was saying, for example, R5 equal R3 plus whatever is in AC, content of AC. This is not finished لأنه جبنا R3 من هون وجبنا ال AC من هون جمعناهم وحطيناهم بال AC. Now we have one more link, guys. شو هو link? I have to store it back in R5. مظبوط ولا لا? So this will not maybe directly go here. In my design, I will go here to a buffer. And this buffer will have AC and will have here a buffer. So the answer will be registered here and here. And this will go and join registers. Are you okay, guys? This is my design. ما حدا يضحك علي هيدا this is my design. Okay. These are address lines, guys. هاي يعني ما تفكر انه هن شيء address lines بيحملوا register number and something. Addresses, we know why. Maybe I'm storing something, maybe I'm loading something. So some of these will hold addresses. Give me an address, guys, of an address we used in our numerical example at the beginning of the lecture. The base register تبع الارray. This will not change every minute, guys. In my program, base register, let's call it this. Or register base, or anyway. Once Once, suppose this is the base register. Once you load here, in the example, it was 200, مش هيك? Once you load here 200, then this will stay all the time with you from the beginning of the execution of your program until the end. Till the end. Condition code. When you say, guys, jump accumulator is 0. هلا شفناها مش هيك؟ jump accumulator 0 or skip accumulator. شفنا skip accumulator 0. شو بيعمل هيدا guys؟ هيدا 3 my time is out. يلا خلص I'm finalizing. It will look into the accumulator and in one of the registers that carry condition code, guys. Register that carry condition codes here somewhere. A register. بحط هون for example true as an answer of checking if the accumulator is 0. So this is true. And then it continue and check if this condition code اسمها CC عادة CC we call it here yeah CC condition code. If the answer of this check is true, then I skip. If not, then I don't skip. If I continue with that, what does that mean, skip, guys? PC was pointing to the next instruction. If I want to skip it, what do I do? What do I do? PC++. And this is the execution of this instruction. Maybe we start from here next time. If you didn't understand it, you just need to tell me, please start from the last point we have said. After طبعا you listen to the recording once, twice, 3 times. Maybe we write it in Java. This high, we write it in Java. Why not? Why not? We consider it as a firmware. Logical unit can have software somehow in the chip, and then it will work. Okay, thank you for listening. I hope that you got most of the material. Please, you go through this recording many times and prepare yourself for any question I ask next time. I will stop recording. And now